Hello friends, welcome to my YouTube channel. So this video is on most important questions which are going to be asked in second PUC midterm examination for sure from alcohols, phenols and ethers. Okay, so first is esterification reaction, the reaction between carboxylic acid and an alcohol in the presence of concentrated sulfuric acid H plus to give an ester and water to give ester. Really important. Okay, there is a carboxylic acid and alcohol. इन दोनों में से वाटर पानी निकाल लो तब तुम्हें मिल जाएगा एस्टर. Okay, and add this. That's what it is, man. So for example, acetic acid in methyl alcohol, methyl estate, benzoic acid, ethanol CH2CH3 पानी निकाल लो तो आ जाएगा ethyl benzoate. Next is Lucas reagent. It is a mixture of anhydrous zinc chloride and concentrated HCl. The time taken for appearance of turbidity with Lucas reagent is different in three types of alcohols. It is used to distinguish primary, secondary and tertiary alcohols. Organic compounds plus Lucas reagent, that is anhydrous zinc chloride and concentrated hydrochloric. So tertiary alcohol, secondary alcohol, primary alcohol. So for the tertiary alcohol gives immediate turbidity, secondary alcohol gives turbidity after 5 minutes and it gives turbidity on heating. Mechanism of dehydration of ethanol to ethene. So there are two steps. There are three steps. So short form is, remember, PCP. First, protonated alcohol, carbocation and proton. Okay, formation of protonated alcohol, formation of carbocation, elimination of proton. Here as we are talking about ethanol, C2H5OH, ethanol, यहाँ पे H plus होगा, formation of protonated alcohol. As you know, there is a nucleophile, this will come and attack. Okay, ethanol बन जाएगा protonated alcohol. Next, formation of carbocation is nothing but the deficient of electron, which means यहाँ पे हम कुछ निकालने वाले हैं. Protonated alcohol loses the water molecule. See here, protonated alcohol loses the water molecule to form carbocation. It is the slowest reaction, which means it is rate determining step of the reaction. Now step 3 is that elimination of proton. Now carbocation, we got carbocation. Now we are removing this proton from carbocation to form an alkene. It is ethene. And the rate of reaction proceeds like tertiary more than secondary more than primary. See guys, there are three steps. First, PCP, formation of protonated alcohol, formation of carbocation and elimination of proton. Okay, here it will attack like this. It will form protonated alcohol, slow reaction, which is rate determining step. ये निकाल दो and then you will get carbocation, and carbocation को आप प्रोटॉन निकाल दो तो ईथीन बन जाएगा. नेक्स्ट इज फिनॉल से क्यूमिन कैसे करना है. तो phenol from cumin, not phenol से cumin. So you're gonna take cumin. Cumin is nothing but a benzene attached with this CCC. With this three, there are three C, like that. In the presence of air, cumin isopropyl benzene is oxidized in the presence of air to give cumin hydroperoxide. So here, just look at these. They both remain the same. And add double O, right? Because we are using oxygen, then use it over here. That's it. When you get cumin hydroperoxide, just remember the name. And peroxide, we use the name peroxide when there is O bond, right? For treating with dilute acid, not concentrated, to give phenol and acetone. That's it. So take cumin, which is isopropyl benzene, the presence of air 100 to 130 degrees Celsius, convert into Fahrenheit. I will get cumin hydroperoxide, that is at OO. In the presence of dilute acid, you will get phenol and acetone. Next, as alcohols are less acidic than phenols because in alcohols an alkoxide ion is not stabilized by resonance. In phenol, as you know, there is this kind of resonance, but in alcohol it is not seen. Hence they are less acidic than phenols because in alcohol an alkoxide ion is not stabilized by resonance, whereas in phenol it is stabilized. Now phenol reacts with nitric acid in the presence of concentrated sulfuric acid to give picric acid. Picric acid is nothing but 2,4,6 trinitrophenol, which is known as picric acid. Phenol reacts with concentrated nitric acid in the presence of concentrated sulfuric acid. Both are concentrated here to give picric acid. Bromination of phenol. The word bromination itself says that there is addition of bromine. Okay, look, there are two types of bromination. In one, there is addition of bromine in three sites, but in the next, there is addition of at least only one side, either ortho or para. And in this, we'll get para while the product is major, which is 80%. So let's talk about the first bromination process. We'll take phenol. In the presence of bromine water, you'll get picric, not picric. If it is nitro at 2,4,6, you'll get picric. It is not picric. It is 2,3,4. Sorry, 2,4,6. Guys, please change this. It's tribromo-phenol. Phenol reacts with bromine water to give white precipitate of 2,4,6 tribromo. I wrote correct here, but not here. Phenol reacts with bromine and carbon suboxide, carbon disulfide, and chloroform to give ortho and para bromophenol. Okay, bromine in CS2 or CHCl3 in at 273 Kelvin. Get this. Next is Kolbe's reaction. What is Kolbe's reaction? Phenol to salicylic. So here phenol reacts with sodium hydroxide to form sodium phenate. O minus H plus OH minus Na plus, right? So these both of them will join together and form sodium phenate, and then there are the next two processes followed. One at 413 Kelvin and 6 to 7 atmospheric pressure in the presence of carbon dioxide gives sodium salicylate, which on acidification gives salicylic acid or 2-hydroxy benzoic acid. Okay. Phenol in the presence of sodium hydroxide forms sodium phenate, and then in the presence of 413 Kelvin and 6 to 7 atmosphere in carbon dioxide, it gives sodium salicylate, which on acidification gives salicylic acid. Next is Riemann-Diemann reaction. Here, phenol reacts with chloroform in the presence of aqueous and avoids 340 Kelvin and forms this in the presence of sodium hydroxide. Yes, you see here it is CHCl2, it will become CHO, and here ONA, it will become OH. So like this. And you will get salicylaldehyde. Phenol in the presence of chloroform and aqueous KOH in the at 340 Kelvin followed by hydrolysis gives orthohydroxybenzaldehyde, which is called as salicylaldehyde. When phenol reacts with zinc dust, what happens? When phenol reacts with zinc dust on heating gives benzene. It is so simple. Williamson ether synthesis, RONA, sodium alkoxide, alkyl halides on heating with sodium alkoxide in alcoholic medium. Alkyl halide on heating with sodium alkoxide, RONA. Alcoholic medium SN2 gives ethers here. CH3ONM. This is sodium methoxide, and alkyl iodide gives ether. Okay, CH3O, CH3 and NaI. So here, just write like this and add this. You'll get it. Now the four reactions of electrophilic substitution, reactions of anisole, bromination, nitration, Friedel-Crafts, alkylation, Friedel-Crafts. So these two reactions are also seen in haloalkanes and haloarenes, which I made a video. Please go and check. Bromination. So you'll get anisole. This is anisole, guys. This is anisole. Just remember, it is like this kind of benzene attached with OCH3. In the presence of bromine, CH3COOH, you will get an ortho and a para wala product, and your ortho wala is major. Bromine plus CH3COOH, methanoic acid. Nitration, nitric acid, and sulfuric acid. You'll get ortho and para. Okay. Fuel-calf alkylation, fuel-calf acylation. In alkylation, it is chloroform and ALCL3. Again, add ortho para. In fuel-calf acylation, only the reagents is different. Here it is this acetone and anhydrous aluminum chloride. See, CH3, CH3 substitute. Here C double bond O, CH3 substitute here. So easy. The last question, ether cleaves to form an alkyl halide and alcohol. Alkyl alcohol. How does it cleave? In the presence of limited amount of concentrated hydrogen iodide and excess of concentrated hydrogen iodide? An alkyl ether reacts with one equivalent of concentrated hydrogen iodide to produce an alkyl iodide and also an alcohol. There are two steps when there is presence of excess of concentrated hydrogen, step 1 and step 2. See here. So you will get C2H5OH and C2H5I finally. An alcohol intermediate is formed in first step, which reacts further with excess hydrogen ion. Because it is excess, so it will further react to produce second molecule of alkyl iodide and water. And that's it, guys. So Friedel-Crafts alkylation and acylation, also it in the last chapter where I got it, so that it will be easy to remember. Friedel-Crafts alkylation, Friedel-Crafts acylation. We use this and this. We use this and this. Right? Acetyl chloride. But here it is chlorine in the presence of anisole. It is chlorobenzene. But there it is anisole. Again, like this. Let's go back. See here. CH3OCl, acetyl chloride. That's it for the video, guys, and thank you so much for watching the video. Like if you found it helpful, subscribe, and stay tuned for the chapters. Bye bye.